Good morning, everyone. I am Prasanna. My final year project is Big Data Evaluation, a deep dive into gradient descent and smart data analytics. Let me give you a small introduction about my project. In this century, the data is being generated exponentially. Handling this huge amount of data is a big problem in machine learning because it is causing curse of dimensionality problem. This curse of dimensionality problem can be solved in two ways. One is feature selection, another is feature extraction. My project is about one of the feature extraction technique called principal component analysis. Principal component analysis is a dimensional reduction technique which is used to transform high dimensional data into lower dimensional. In PCA, 90% of overall variance are retained in the dataset. Principal component analysis is applied to lung cancer dataset in my project, and the lung cancer dataset is also deployed. Let me show you the code of my lung cancer dataset. This is the Google Colab of lung cancer dataset. We started our project by importing the statements necessary libraries like NumPy, Pandas, Matplotlib, sklearn. The dataset is downloaded from the Kaggle and open source for all the datasets. This is the description of the data. This is the information about the data. Seaborn library is used to visualize the data. Correlation matrix is constructed and then pre-processing steps are followed. One-hot encoding is also performed on the dataset. Here you can see the visualization of correlation matrix. Dataset is split into training dataset and testing dataset. Standardization step is an important in model building. It is also being performed. Logistic regression, support vector machine, random forest models are used. Here you can see the accuracy of each model. Confusion matrix is also constructed. Now you can observe the time taken for model building. Here the time taken is 0.008 seconds. Now comes the important part. Principal component analysis. Initially 16 features are used to build the PCA. But in this graph, you can observe that 14 features are sufficient. After that, the variance is standardized. So we can conclude that 14 features are sufficient to capture the overall variance. So now the number of features has become 14. This is the final dataset after reduction. Here, the first principal component 1, PC1, captures the maximum variance. Remaining dataset techniques have also been implemented. Logistic regression is used to build the model. Here, you can see the time taken to execute the model is 0.005 seconds. So, you can clearly observe the reduction in time taken to execute the model. Confusion matrix is also being constructed. In machine learning, we have three main optimization techniques: gradient descent, stochastic gradient descent, mini-batch gradient descent. So, these three optimization techniques have been compared with PCA and without PCA. Here you can see the accuracy without PCA. And then here you can see the accuracy with PCA. Same can be visualized with the bar plot. Now let's see the deployment part. This is the file where I saved my complete project. Let me open the command prompt. Already virtual environment is created. Now let me activate the virtual environment by using this command. Here you can clearly see that the virtual environment is activated. Now let's run the project. Oh, there is a small typo error. Let me correct that. Here you can see that the project is running in the local host. It's taking some time. Here you can see that The user has to enter the required inputs for the production. Let me give the inputs. After entering the inputs, you can see the output. The individual may have the lung cancer, and here you can observe the necessary precautions to be taken. Thank you. This is my complete project.